Nature is full of wonders, but few creatures are as vital or as fascinating as bees. These tiny insects have shaped ecosystems for millions of years, perfected complex societies, and provide essential services that sustain human agriculture and biodiversity. In this video, we will explore the remarkable life of bees, focusing primarily on the honeybee and examine how their highly organized colonies function with incredible efficiency. From birth to foraging and communication, we will recover the science and wonder behind one of nature's most sophisticated societies. Join me as we dive into the world of the bee. While there are over 20,000 species of bees, the European honeybee is the most well-studied and economically significant. Honeybees are eusocial insects, meaning they live in large, cooperative colonies with a clear division of labor. A typical hive contains 20,000 to 60,000 bees. At the heart of the colony is the queen bee, the only fertile female. She can live for several years and lays up to 2,000 eggs per day. Worker bees are sterile females who perform nearly all the tasks in the hive. Drones are male bees whose primary role is to mate with a new queen. They do not forage or defend the hive and are expelled during times of scarcity. This sophisticated caste system ensures the colony's survival through specialization and cooperation. The life of a honeybee begins in a hexagonal wax cell. The queen lays a fertilized egg that develops into a worker or queen, or an unfertilized egg that becomes a drone. For the first 3 days, all larvae are fed royal jelly, a nutrient-rich substance produced by worker bees. After that, worker larvae switch to a diet of pollen and honey, while queen larvae continue receiving royal jelly, which triggers the development of reproductive organs. After about 6 days as a larva, the bee pupates. Around 21 days after the egg is laid, a new worker bee emerges. Her first tasks are inside the hive cleaning cells, feeding larvae and tending to the queen. As she ages, she graduates to building comb, guarding the hive, and eventually foraging outside. A worker bee's lifespan is typically 4 to 6 weeks during the busy summer months, but up to several months in winter. Worker bees exhibit age-based polyism, a remarkable division of labor. Young workers handle nursing, cleaning and wax the honeycomb, process nectar into honey, and guard the entrance. Older workers become foragers, flying up to 5 kilometers from the hive in search of nectar, pollen, water, and propolis. A single foraging trip can involve visiting hundreds of flowers. Foragers communicate the location of rich resources through the famous waggle dance, a figure-8 movement on the honeycomb that conveys both direction relative to the sun and distance. This sophisticated symbolic language allows the colony to optimize foraging efforts efficiently. Inside the hive, bees maintain a precise temperature of around 95 Fahrenheit through collective wing fanning for cooling or clustering for warmth. They also defend the colony fiercely using their stingers, which are barbed and cause the bee's death upon use against mammals, an ultimate sacrifice for the greater good of the hive. One of the most impressive feats is honey production. Foragers bring nectar back to the hive, where house bees enzymatically process it, reducing water content through regurgitation and evaporation. The result is honey, a stable antibacterial superfood that can last indefinitely. A strong colony can produce 20 to 50 kilograms of honey per year. Beyond honey, bees produce beeswax for comb, royal jelly, propolis, and venom. Most importantly, as they forage, bees are unparalleled pollinators. They transfer pollen between flowers, enabling reproduction in approximately 75% of the world's flowering plants and 1/3 of human food crops. Without bees, many fruits, vegetables, and nuts would disappear from our tables. Despite their resilience, bees face serious threats. Colony collapse disorder, pesticides, habitat loss, climate change, and diseases like varroa mites have devastated populations in many regions. Beekeepers and scientists are working on solutions through improved hive management, breeding resistant strains, planting pollinator-friendly gardens, and reducing pesticide use. Supporting local beekeepers and protecting natural habitats are crucial steps every individual can take.